In the afternoon on April 2026, a piece of the solar system traveling at 30,000 miles per hour entered Earth's atmosphere 48 miles above the Atlantic Ocean off the coast of Mastic Beach on Long Island. And before anyone had time to reach for a phone, it had already crossed 117 miles of sky, fragmented into multiple burning pieces visible in 6 states simultaneously, and disintegrated 27 miles above the town of Galloway, New Jersey, in a flash of green and blue light bright enough to be seen through broad afternoon daylight by more than 274 people who reported it within hours to the American Meteor Society. This was not a nighttime spectacle. The sun was up, the sky was blue, and still it burned bright enough to stop people on sidewalks in Pennsylvania, Delaware, Connecticut, New York, and New Jersey, faces tilted upward, watching something ancient fall through modern air. If you rely on this channel for science grounded in verified data and explained with honesty, subscribing ensures that none of this reaches you late. This work depends on the audience that values it. Every figure in this script was drawn from official scientific and governmental sources, NASA, the American Meteor Society, NOAA, other public sites before any decision is made, whether personal, professional, or otherwise, verify independently through the official channels. The sources are public, the data is accessible, the responsibility to check belongs to all of us, but that is not even the complete picture. Because what streaked across the eastern United States on April 7th was not a singular event that arrived without warning and will not return. It was the latest episode in a pattern that the American Meteor Society now formally says warrants serious investigation, a documented, statistically significant surge in large fireball events across the Northern Hemisphere that began in January 2026, accelerated through February, and reached an intensity in March and early April that has no clear parallel in the 15 years of modern fireball records the Society maintains. The April 7th fireball is the visible tip of something the scientific community is only beginning to understand, and what they are finding beneath that visible tip, in the trajectory data, in the radiant analysis, in the recovered meteorite fragments, and in the orbital geometry of the inner solar system, is a picture that should command far more attention than a doorbell camera video shared on social media. To understand what is actually happening, you need to understand what it takes for a rock from space to be seen in daylight. The sky is bright enough during afternoon hours that even significant light sources, as fires, flares, explosions, are routinely invisible from altitude. For a meteor to outshine the scattering of full sunlight, it must reach a luminosity greater than the planet Venus, which is itself the third brightest object in Earth's sky after the sun and the moon. NASA defines this threshold formally. A fireball is any meteor brighter than Venus. A daytime fireball must be brighter still, brighter than the diffused light of an entire sun-washed atmosphere. The April 7th object cleared that threshold with enough margin that witnesses described a flash of brilliant green followed by fragments trailing red, orange, and white as they separated, a blue tail, visible fragmentation, a luminous train that lasted seconds after the object had passed. This was not a pebble. This was a mass of rock that entered the upper atmosphere at hypersonic speed, converted its own kinetic energy into light through friction with the air column, and produced enough photons per second to penetrate the glare of midday. Now consider this. 274 people reported it, and those are only the ones who knew where to file a report. The American Meteor Society collects voluntary submissions. The true witness count for a fireball crossing the most densely populated corridor on the eastern seaboard, over Long Island, over New Jersey, over Philadelphia's suburbs, is orders of magnitude larger. Millions of people live within line of sight of that trajectory. People at outdoor tables, people at windows, people on rooftops in Brooklyn and in backyards in central New Jersey and driving on the New Jersey Turnpike. The woman named Kristen D. in Pennsylvania who submitted her report and described watching it pass high above the tree line before it vanished behind the horizon. The New York resident Joanna C., who saw a flash of blue and said it flew faster than anything she had ever seen. No sound, no trail, gone in under 3 seconds. Real people, not instruments. Human beings who looked up and saw something that should not have been there in the middle of a Tuesday afternoon, and who felt in that moment an entirely rational confusion about the permanence of the ordinary sky above them. Here is where this account becomes genuinely significant. The April 7th event did not arrive in isolation. It followed a sequence that, once laid out in chronological order, reads less like random coincidence and more like a statement from the solar system about the density of what Earth is currently moving through. On March 8th, a slowly disintegrating daytime bolide passed over Western Europe. An astonishing 3,229 people reported it to the American Meteor Society, the single highest witness count for any fireball event in the Society's modern database. On March 9th, a fireball seen by 282 people crossed the U.S. eastern seaboard. On March 10th and 11th, 2 additional events over France together generated 381 reports. On March 17th, a 7-ton asteroid approximately 6 feet in diameter screeched above Ohio and Pennsylvania during morning hours, produced a sonic boom loud enough that the National Weather Service in Cleveland confirmed it, burned so intensely that NOAA's GOES weather satellite lightning mapper detected the flash from orbit and generated more than 200 witness reports submitted to the AMS. On March 21st, a meteoroid of approximately 1 ton broke apart over the Houston metropolitan area, producing an airburst equivalent to 26 tons of TNT. The sonic boom shook houses. A dark, jagged fragment of rock punched through the roof of a home in the Ponderosa Forest neighborhood north of Houston and ricocheted around a bedroom. On March 23rd, 2 separate California events generated 306 and 122 reports respectively. On March 24th, a bright fireball over the Midwest and Ontario drew 111 reports. On March 9th, a meteor over western Germany produced recoverable meteorite fragments near Koblenz. By the end of March, the first quarter of 2026 had logged 2,322 total fireball events, with 40 events seen by 50 or more witnesses, and 16 events seen by 100 or more witnesses. Those last 2 numbers are more than double any comparable baseline from the preceding 5 years. Mike Hankey, who manages fireball reporting tools for the American Meteor Society and authored the formal analysis of Q1 2026 data, stated in his published report, "After years of stable baseline activity, something appears to have shifted. The signal is consistent across multiple metrics." And then he said something that is worth reading twice, because scientists choose their language carefully here. And that careful language is itself the warning. He wrote that the number of large fireball events seen by 50 or more witnesses has roughly doubled compared to the 5-year average. Not total events, not small events, the large ones. The ones that rattle windows, that produce sonic booms, that deposit fragments on rooftops, those have doubled. This is not a hypothesis. This is documented in the data that the American Meteor Society has collected continuously since 2011. The question is not whether something has changed. The question is what changed and why, and what it means for the months ahead. The answer the data currently points toward begins with a region of space called the Anthelian sporadic source. Imagine standing on the surface of the Earth and drawing a straight line from your feet through your body, up through the crown of your head, through the atmosphere, through space, directly toward the sun. Now imagine the exact opposite direction, the line extending out from the soles of your feet into the space directly behind you, the point in the sky sitting geometrically opposite the sun. That point is the Anthelian. Objects approaching Earth from the Anthelian direction are moving in roughly the same orbital direction as Earth itself. They are fellow travelers of the inner solar system, following orbits similar to our own, catching up to our planet from behind as both we and they spiral inward around the sun. Because they approach from behind rather than head-on, the relative velocity of impact is lower than for meteors arriving from other directions. In 2026, the American Meteor Society found that activity from this Anthelian source has approximately doubled compared to any prior year in the modern record. Nearly 10 of the largest events, including several of the events named above, originated from a single 1,000 square degree patch within the Anthelian zone. The Poisson statistical analysis applied to this concentration registers at 4.1 sigma. For reference, particle physicists use 5 sigma as the threshold for claiming discovery of a new phenomenon. At 4.1 sigma, the concentration of Anthelian fireballs in 2026 is not random scatter. It is a real signal, something in the debris field of the inner solar system that normally produces a steady background rate of large incoming objects has, in 2026, produced significantly more of them. A second cluster appears in what the AMS describes as high declination radiants, objects traveling on steeply inclined orbits, almost perpendicular to the flat plane of the solar system, arriving from regions of sky above 70 degrees declination. In 2026, 11 events were identified from high declination radiants, compared to a previous maximum of 5 in any prior year. The Poisson significance for this cluster registers at 4.3 sigma. 2 separate, statistically robust concentrations, the Anthelian enhancement and the high declination cluster, occurring simultaneously. The AMS formal position is that this warrants serious investigation. What that means in practice is that the data has moved beyond the zone of plausible statistical noise into a zone where something physically real must be proposed to explain it. This is not a hypothesis. This is documented in the geological record that stretches across billions of years of Earth's history with incoming space material. This has already happened before. In 2013, a meteoroid estimated at approximately 10,000 metric tons entered Earth's atmosphere above the Russian city of Chelyabinsk at 42,000 miles per hour. It released energy equivalent to approximately 500 kilotons of TNT, 30 times the yield of the atomic bomb dropped on Hiroshima. The airburst shattered windows across 6 cities. The shockwave injured 1,491 people, most of them from broken glass. It arrived without warning. No telescope had detected it before entry. It came from the direction of the sun, a blind spot in the global monitoring network. Chelyabinsk had a population of approximately 1.13 million people at the time. The object that struck them entered in daylight. It was not seen until it was already inside the atmosphere. Then it was impossible to look away. Go further back. On June 30th, 1908, something entered Earth's atmosphere over the remote Tunguska River region of Siberia. The object, estimated between 50 and 80 meters in diameter, roughly the size of a large office building, detonated in an airburst approximately 5 to 10 kilometers above the surface. The explosion flattened approximately 2,150 square kilometers of forest. Approximately 80 million trees were knocked down by the pressure wave. The event registered on barometric pressure gauges around the world. Eyewitnesses dozens of kilometers away reported being knocked off their feet. No crater was formed. The object never reached the ground. It simply ceased to exist as a solid body at altitude, and the energy of that cessation scoured the taiga clean across an area larger than metropolitan London. Tunguska happened in one of the most remote inhabited regions on Earth. The population at the epicenter was essentially zero. Had the orbit of that object been shifted by a matter of hours, by the rotation of the Earth beneath it, it would have struck a city. The question the geological record asks, and does not answer gently, is not whether this kind of event occurs. The question is when it occurs next, and what is below it when it does. The recovered meteorite fragments from the 2026 events carry their own message. The specimens recovered from the Ohio and Germany events in March, falling 9 days apart, have both been classified as chondritic eucrites, a rare type of meteorite formed from igneous rock in the crusts of ancient differentiated asteroids. They are, in the language of researchers, head meteorites, howardite eucrite diogenite, a mineral family associated primarily with the asteroid Vesta, one of the largest bodies in the main asteroid belt between Mars and Jupiter, with a diameter of approximately 525 kilometers. Vesta is a world in its own right. It was studied in detail by NASA's Dawn spacecraft between 2011 and 2012. Its surface bears the scars of ancient impacts that sent debris across the inner solar system. That debris, excavated billions of years ago, orbiting quietly ever since, is what researchers believe they are now holding in their hands in Ohio and Germany. The rocks are 4.5 billion years old. They formed when the solar system itself was new, and they have spent that entire span of time traveling an orbital path that, at this precise moment in history, has intersected with ours. Consider for a moment what it means to live in Galloway Township, New Jersey. It is a quiet community northwest of Atlantic City, with a population of approximately 37,000 people. Its residents go to work, send children to school, shop at supermarkets. On the afternoon of April 7th, something traveling at 30,000 miles per hour disintegrated 27 miles directly above them. 27 miles. The height above their heads at which this object ceased to exist. A cruising altitude for a commercial aircraft is approximately 7 miles. The April 7th fireball disintegrated nearly 4 times higher than that. The energy it released was distributed across the upper atmosphere rather than concentrated at the surface, and so the residents of Galloway Township felt nothing, heard nothing, were aware of nothing until the videos appeared online that evening. But this is the architecture of the situation. The difference between an event that produces a viral doorbell camera clip and an event that produces a crater or a shattered city is the altitude of disintegration, the height at which the object's structural integrity finally fails against the compressive force of the atmosphere. That altitude depends on the size, composition, speed, and angle of the incoming object. For April 7th, the parameters were such that disintegration occurred high enough to spare the surface. Those parameters are not fixed. They vary with every object that arrives. Now consider the system within which this is occurring. Earth does not orbit in empty space. It moves through a solar system whose near-Earth environment is shaped and continuously perturbed by gravitational resonances, primarily those of Jupiter, whose mass dominates the orbital dynamics of the asteroid belt. When asteroids in the belt occupy orbits whose period is a simple fraction of Jupiter's orbital period, they receive repeated gravitational nudges that destabilize those orbits over time, gradually shifting them into paths that cross the inner solar system, paths that cross Earth's path. This is called orbital resonance, and it is the primary mechanism by which the inner solar system receives a continuous slow rain of material from the asteroid belt over geological timescales. The AMS researchers who analyzed Q1 2026 data note that the head meteorites recovered in Ohio and Germany, though belonging to the same mineral family, both consistent with Vesta-derived material, arrived from orbital trajectories separated by 98.2 degrees. They did not come from a single fragmented parent body traveling together. They came from separate objects on separate orbits, both of which intersected Earth's path within 9 days of each other. The analysis cannot yet determine whether this is a meaningful concentration of Vesta family material in Earth's orbital neighborhood or a coincidence of timing within normal background variation. That determination requires continued observation, continued data collection, and a monitoring infrastructure that is, by the AMS's own assessment, presently inadequate. Think of what that inadequacy means in concrete terms. When the 7-ton asteroid burned over Ohio on March 17th, the only AMS-affiliated all-sky camera in the state of Ohio was offline. A 7-ton rock crossed the sky, triggered a sonic boom, produced a flash detected by a weather satellite in orbit, and there was no ground-based instrument recording it from within the state it crossed. The trajectory data for that event was reconstructed from crowdsourced eyewitness accounts, from people standing in parking lots and looking out kitchen windows and recording from dashcams on their way to work. That is the current state of Earth's ground-based monitoring infrastructure for incoming space objects at the fireball scale. The Chelyabinsk object in 2013 was also undetected before entry. In the intervening 13 years, the monitoring gap at the lower end of the size scale, objects too small to be caught by telescopic asteroid surveys, too large to be dismissed as harmless, has not been closed. Researchers are calling formally for expanded automated all-sky camera networks capable of independently calculating a rock's mass, velocity, and orbital origin the instant it strikes the atmosphere. Those networks do not yet exist at the necessary density. The science is ahead of the infrastructure. The data is telling us that the sky is active. The instrumentation to fully characterize that activity is not in place. Think also about the people in the small observatory communities, the amateur astronomers, the backyard camera operators in suburban New Jersey, who have spent years building their own fireball networks precisely because the official infrastructure is sparse. These are the people who submitted 274 reports on the afternoon of April 7th before NASA had issued a formal advisory. They are the early warning system that formal institutions rely on to reconstruct events they did not directly capture. Their data, messy, human, drawn from front doors and parking garages and school playgrounds, is what makes trajectory calculations possible for events that no calibrated scientific instrument recorded in real time. That is the state of the art. And the state of the art is being tested by a surge in large events that the AMS says has no clear parallel in 15 years of modern record keeping. Connected systems matter here. The 2026 fireball surge is not occurring in isolation from other solar system dynamics. The Earth is currently approaching peak fireball season, which NASA identifies as running from February through April, a period when our orbital position and the geometry of the anthelion source combine to maximize the frequency with which Earth sweeps through background meteoroid populations. But the enhancement observed in 2026 exceeds what peak fireball season alone would predict. The American Meteor Society's statistical analysis found that the anthelion concentration this year registers at more than double the previous maximum density. Fireball season explains a baseline elevation. It does not explain doubling. There is also preliminary work on what one data analyst reviewing the AMS release identified as a 13-day periodicity in the Q1 2026 fireball event counts, a pattern that, if real, corresponds to the Carrington half-rotation interval, the period between solar wind sector boundary crossings as the sun rotates. Whether geomagnetic conditions influence the apparent frequency or observability of fireball events is not yet established science, but the signal, if it holds under further analysis, points toward a connection between solar wind dynamics and the detection envelope for near-Earth meteoroid events, a connection that would mean the sky above Earth becomes more active in ways we can detect during certain phases of the solar wind cycle. That is not yet a confirmed result. It is a thread being pulled by researchers who are seeing something in the data that they cannot yet fully explain. Scientists choose their language carefully here. The careful language is, this warrants serious investigation. The Lyrid meteor shower is scheduled to peak on the night of April 21st and 22, 2026, with the moon 27% full, conditions favorable for observation. The Lyrids are a moderate shower capable of producing fireballs. They arrive from a radiant near the constellation Lyra and are associated with the debris trail of Comet C 1861 G1 Thatcher. In a normal year, they are a modest annual event. In a year where the background sporadic fireball rate is already significantly elevated, the Lyrids will arrive into an already active sky. Whether the interaction of the Lyrid stream with the elevated sporadic background produces measurably more or larger events is unknown. It is one of several open questions that the current data has placed in front of the scientific community without providing an answer. The Galloway Township resident who steps outside on an April morning and tilts their head back does not see the catalog of events described in this script. They see a blue sky. They feel the warmth of the same sun that has risen over that stretch of New Jersey coast for 4.5 billion years. They have no reason to feel unsafe. The risk that any given person will be struck by meteorite debris from a fireball event of the scale observed on April 7th is, in the language of the NASA advisory, not a real hazard to ground dwellers in typical circumstances. That statement is correct. It is also, in the longer view of planetary history, the statement that is true right up until it is not. The monitoring is in place for the largest known near-Earth objects, those big enough to be tracked by telescopic surveys years in advance. The monitoring is not in place at adequate density for objects in the size range that killed 1,491 people in Chelyabinsk, that leveled a forest larger than a European capital at Tunguska, that punched through a roof in Houston in March 2026. The system is not inactive, it is accumulating data. And the data it is currently accumulating in the quarter that began this year is telling researchers something they cannot yet fully interpret. On April 7th at 2:34 in the afternoon Eastern Daylight Time, a rock formed 4.5 billion years ago in the crust of a shattered world crossed 117 miles of sky above one of the most densely populated regions on Earth in approximately 14 seconds, broke apart in a flash of green and blue light, and rained its remnants, if any survived to the surface, somewhere in the ocean or the pine barrens of southern New Jersey, unrecovered, unexamined, already beginning the process of terrestrial weathering that will, over the centuries, erase all chemical record of its origin. The people below it went back to their afternoons. The traffic on the New Jersey Turnpike continued. The instruments that were working recorded what they could. The instruments that were offline recorded nothing. And in a server somewhere maintained by the American Meteor Society, a counter that has been running since 2011 recorded one more event in a quarter that is already unlike any other in the modern record. A quarter in which the solar system has been doing something that scientists say, with careful language and appropriate caution, they have not seen before and do not yet fully understand and cannot predict the continuation of. The geological record does not record close calls, it records only arrivals, and it is very long.